All right, what should we talk about today? So today's lesson is on working with exceptions. So we've talked about try-catch. We've talked about try-catch. We talked about throw. We talked a little bit about checked exceptions last time and how in certain cases the compiler can require that we handle an exception. So a couple new ideas here to start off today's lesson. A couple new. So one question people might have had is, what happens if I throw out of a catch block? So we talk about that. That's not necessarily always a mistake. Sometimes that's exactly what you want to do. Throwing out of a catch block can allow you to, and particularly when you're working with Android, right? Now, when your Android app crashes, you'll typically get some log messages that'll help you pinpoint the problem. But there are other times when something happens that you're not expecting, and you might have a way to deal with that, but you're not, it indicates like something's off, there's like a bug in the matrix. And so one way to, at least in development, to sort of examine this is to do something where, you put the code that might produce this type of offending error inside a try-catch, you catch the error, and then you log it, right? And so that's one use for catch. Actually, sorry. So there are times when something goes wrong and maybe you want to do a little bit of extra logging before it crashes. When something crashes, you get a certain piece of information out of Android, or out of other Java type systems, typically a stack trace, that will lead you back. It'll sort of say, okay, this method called this method called this method called this method, where there was an exception thrown that wasn't handled. But sometimes you actually want to see a little bit more information, like what was the state of the world, what were the values of some variables. And so to allow that, you can wrap things in a try-catch, still throw the exception out of the catch block, but do a little bit of logging first, right? The other use for this, and we talk about this later in the lesson when we talk about some patterns for handling exceptions, is that you can also use this to convert a checked exception to an unchecked exception. So you can take a checked exception that the compiler is forcing you to handle, wrap it in a try-catch. Inside the catch, wrap it in like an illegal state exception or another runtime exception. That will and then throw that out of the catch statement. At that point, the compiler is like, well, this is an unchecked exception, and it will stop bothering you. Again, so if you look at like any language, Java has some good features and some bad features. It's not clear to me that checked exceptions are a feature of Java that people have decided is universally that is universally helpful. In the sense that there are times when you might have run into this on the MP already, where it's like it's saying, oh, you have this checked exception. It's like, I don't know what to do. Like, I should crash, right? If the JSON is really that messed up, let I get a malformed JSON exception or whatever, then the program should probably crash. That's probably a reasonable thing to do at that point. So, again, in that situation, rather than like adding throws and having to deal with it all the way at the stack, you just be like, look, Java, I get it. Someone who wrote Jackson decided that this was a checked exception, and therefore I'm supposed to think about what to do about it, and I've thought about it, and I think what I should do is crash. So I'll just rethrow it, right, as an unchecked exception. The other new thing here, and this is actually pretty interesting, right? It's this idea of finally, because again, this is another one of these places where Java's exception handling mechanisms will, can confound us a little bit in terms of how we think about code flow. A finally block can be added to a try-catch, and actually it can be added to just a try. A try-catch block doesn't actually have to include a catch. It has to include one or more catch or finally blocks, and I can only have one finally block. The finally block is always executed. If you throw an exception, it's executed. If you don't throw an exception, it's executed. What's interesting about this, as one of the examples here points out, is that the finally block is executed even if there's a return inside the try block. So you'll notice here when we run this piece of code, I see done printed, and then I see it returning 0. Now, to our eyes, it looks like the return 0 happens first, and normally we would think, okay, well the method stops executing at that point. I told you in the past, when we see a return, the method immediately stops executing. I didn't tell you the complete and total truth. If there's a finally block left to run, that will be executed before the method finishes. So it's kind of like Java says, okay, I'm going to return this value, but before I finish up this function, I need to do a few other things. One of the things that I always can never remember, and we'll just try it, is what happens if, there we go, right. So the finally block can also modify the return value, apparently, which is weird. Normally a finally block doesn't need to return, but it looks like if I return something, let's try to return like something that's not a, yeah, okay, fine. It looks like if I return out of a finally block, that return value now overwrites the return value that was established in the try. Let's see. Let's try this. Can I also put the return inside? And the reason for that is I probably can turn. Yeah, there we go. I can put the return inside the finally if I want to. And you might ask, what's the point of this mechanism? It turns out that this type of pattern can be very useful. We haven't seen a lot of situations like this, just because of the type of code that we've been writing. But you probably will encounter them in the future. It's not uncommon for a method to do some things as it gets started that it needs to undo later. So for example, in Android, just to give you one example, not something that you have to work with as part of our project, Android has something that's known as a wake lock. A wake lock in Android is what it sounds like. It's a mechanism for keeping the phone awake. So an app can prevent the phone from sleeping for a period of time. And there's all sorts of rules and restrictions about how this works, and you can go read the documentation if you're curious about it. And this may be something that you need to work with in apps that you build in the future. So you might have a method that when it starts out, it's going to, basically tell Android, don't go to sleep. And that's going to do some work. Now, maybe the thing that it does fails. Maybe it needs to use the network and the internet goes off, right? Or maybe it needs to use some other thing, or maybe it's waiting for the user to do some input and the user doesn't do it in a certain period of time or whatever. There's lots of ways that can go wrong. But it sort of doesn't matter what happens in the method. When the method finishes, I've always got to make sure that before I exit, before the method returns, I tell Android, okay, well now the phone can sleep again if it wants to, right? This is referred to as grabbing or dropping a lock. So when the method starts, I grab this wake lock, that tells Android not to sleep, and when I'm done, I need to drop it. So that's a great place for putting stuff in a finally block, because I don't care what happens in the method. It's possible that it throws. If it fails, it's not important. Whatever happens in the method, whether it succeeds or fails, it always has to make sure that it performs this cleanup. That's sometimes how this is referred. So, one of the things we've looked at in the past is sometimes we do some initialization at the top of a method. Sometimes the things we do at the top of the method, we need to undo at the bottom. Let's do some cleanup. And a finally block can be a great way to make sure that always happens. So what happens, as we looked at catch, what happens if I throw out of a finally? Let's see here. So that's going to work the same way. It's basically going to execute the finally. Okay, so now it's angry with me about a couple things. Let's fix those. So now you'll see that I threw out of the finally, and it wasn't caught because the call to example wasn't wrapped into a try catch, and so the program crashed, right? So if something I'm doing inside a finally goes wrong, like I have a null pointer error or array index out of bounds exception or something like that, then I could have this type of problem. Okay. Questions at this point? I'll pause for just a few minutes, and then we'll go through some of these exception handling patterns that are the focus of the rest of the lesson. But yeah, any additional questions on this before we move on? Yeah. Yeah. I mean, stuff that has to run, particularly at the end of a method or at the end of try catch, right? If you do some stuff inside the try that you need to clean up, finally is a great place to put that cleanup code because it will always run, right? It's like even if there's an error, it runs. So if something inside the try throws, I enter the finally. If the try completes without throwing, I enter the finally. So it's always executed. If you're familiar with Python, Python actually has an interesting twist on this. So Python has a try catch. I think that's what it's called. Maybe it's try. I think it's try except. I haven't written Python. What? Oh, hi. I have a cat here who apparently has something to say today. What? I'm kind of noisy today. You can sit down. The computer's. It's nice and warm, just how you like it. Come here. Oh, okay. There you go. So Python has a try except block. What's interesting about it, they also have a finally clause. What's interesting in Python, and I don't really know if you need this, but Python also has an else, right? So Python has a try except else finally. And so how does that work? So you have a try block where you put code that you're trying to execute. You have an except block where you put code that runs if something in the try block fails. You have an else block where you put things that run after the try block if nothing failed in the try block. And then you have a finally, which runs after everything all the time, right? So it's like, I execute the try. If nothing failed, I get to the else. If something fails, I jump into the except. And if nothing, and after everything is done, if there is a finally block, then that gets executed. So it's a little bit of a wrinkle. I'm sure there's a use case for it, but it seems like, I'm sure there's a use case for it. I'm not exactly sure what the use case is. But anyway. All right. Let's see, try except. What if you mess with references in the try block? I'm not sure. I mean, this is just code, right? So, you can think of try finally as just, if messing with references works in the try block and doesn't cause a problem, then the finally block is just executed afterwards. It's just more code that's run, right? I think the only thing that's a little weird about it is this idea that it can come after a return. And then also obviously sort of modify the return value if it returns, right? So it looks like the semantics of finally are, if I have an extra return inside finally, that is what gets used. If I don't, and the try block return, then the Java will use the return inside the try, which is, again, I guess there's some use cases for this, but great questions. Other questions? I'll give you guys a few more minutes, and then we'll plow forward. All right, so let's talk about a couple of these sort of exception handling patterns. I probably could have added more here, but I could just ran out of space and didn't want to overload you on a Friday. So the first thing to deal with is, and I hate doing stuff like this. I really, when we think about how to present material in this class, I do try to avoid retractions, right? In the sense that I try to avoid teaching you to do something and then later having to be like, oh, no, don't do that. Sometimes it happens. And so, particularly with exceptions, because of how exceptions affect code flow, maybe we should be teaching exceptions earlier. Maybe that's something that we'll try next semester. I don't know. Actually teaching them a little earlier than we used to teach them, or we would teach them even later in the semester. But anyway, so, there are certain types of things that are hard to do right until you know about exceptions. One of them is handling method parameters that have that might have invalid values. The right thing to do there is to use is to throw in a legal argument exception if there's something wrong with the parameter. That's the right way to do it. We've been having you use assert. Now, assert's nice. It's a statement. It's built into the language. it's got this really nice format to it, right? It's one line of code instead of 3 lines of code. So there's some nice things about it, and that's one of the reasons why we decided to teach it this year. But the problem with the cert is that it's not enabled in Java by default. So if you just take Java code and run it in kind of a normal way without doing a little bit of extra work, those assertions are just going to be totally ignored. It's almost as if they're commented out. They just don't get evaluated at all. The rationale behind this, again, this is one of those cases where Java is an old language. And, if you think about it, asserts, evaluating an assert takes time, right? I mean, when Java reaches an assert statement, it has to figure out if the condition is true or not. And that can take time. And so I suspect some languages from around that vintage have this feature for performance reasons. It's like, we'll turn on the asserts when you're testing your code during development, and then we'll turn them off when we ship the code to the client, because then we want it to run as fast as possible. I think today it's a little silly because the asserts don't take that long to execute. I mean, if you're writing code that's really, really performance critical, then yeah, you think about this stuff. But in a lot of cases, it's probably better today to waste a small amount of computer performance in order to establish correctness. Having asserts on probably wouldn't hurt very much Java code. I mean, I think if you just turned asserts on by default and measure the performance impact on most real Java code bases, it would be tiny. But the problem is, Java's an old language, asserts are not on by default. And so in a lot of Java environments, and I looked this up yesterday about Android, and I found some instructions for turning on an assert in Android, and I would not suggest that you try to follow them because they were pretty gnarly and probably not worth doing. So that unfortunately limits the practical ways that we can use assert in our code because we can't rely on it. It might not work. Those asserts that we put in might not do anything. I think the cat's hungry today. I think that's why she's so vocal. Anyway, we have. I love my cat. I also want her to stay healthy, and so we have her on an alternate feeding schedule where it's one day she gets a little bit more food. It's like automatic feeder, right? So every day I kind of toggle it back and forth because she's a small cat, and so she's kind of in between two food settings. I really should be feeding her a certain kind of halfway between the two settings, but I can't. It doesn't have that granularity. So what I do is I alternate. So it's one day she gets less, the next day she gets a little more. So today is the smaller day, which you can tell because she's usually a bit pissed, and then she goes and starts eating the dog food. But whatever. So that's why she's meowing a little more than usual. I don't think there's anything wrong except the fact that she's a little hungry. Because I'm starving her because I don't want her to get fat. That's true. I don't want her to get fat. I don't think it's good for cats to get overweight. So we try to keep her active, and we also try to monitor her diet. Okay, back to talking about assert. So we don't want to use assert. Instead, what we're going to do is we're just going to replace assert with the equivalent code that throws in a legal argument exception when needed. Really noisy today. Where are you? What? Come here. I'm just expecting it down while you're so loud. Oh, come here. You're gonna live. You wanna go for a walk? We'll do that later. All right. So again, the right way to do input validation is just throw in a legal argument exception, right? That's how it's done. This is the pattern. This is the exception to use. This is the pattern when you're checking arguments to a method. I talk about this a little bit later as well, but there's actually, with both of these next two patterns, there's a really important role that documentation plays here, because here's the thing, right? And this is true of a lot of, when you look at Java's types, right? So for example, a Java integer can be positive, it can be negative. There's a lot of cases where negative values passed to parameters don't make any sense. Java doesn't have a type that allows you to express that. So instead, you end up doing this thing where you check to see if it's less than 0, and then you throw a legal argument exception. Well, legal argument exceptions aren't checked. So this is what you're saying is that you called this method wrong. Well, how is the person using your code supposed to know? Again, if it's you, you might do this just to prevent yourself from making silly mistakes, and actually that's a really good idea. But if you were working with a partner or publishing this code online, it's just like, oh, I don't want to find out how your method works by having it throw legal argument exceptions. If you need an argument to have certain conditions, that needs to be in the documentation, right? Then you can enforce them in your code. So the input legal argument exceptions match up with the documentation, right? So the documentation says the int must be even. So you check whether it's even, throw a legal argument exception, right? So now now there's a synergy between these two things. That's also true for the next thing we talk about, which is state validation, right? So if there's a particular way that your class has to be used, where certain methods need to be called in a certain sequence or whatever, same thing there, right? You express it in the documentation, enforce it in the code using state, legal state exceptions or legal argument exceptions. All right. Yeah, well, I'm not hanging out with the cat. I'm just trying to get her to quiet down a little bit. Since I don't want anyone to misinterpret her plaintive cries as if she's being mistreated or something. She's a very spoiled cat. I even got a stroller for her that I push her around in. My wife thinks that's super embarrassing, but she seems to like to be outside, particularly when it's this nice. Okay. Yeah, so let's talk about this. This is one of my favorite uses of try catch because this just opens up this really, and I'll sort of like fast forward to the good part here, right? So this opens up this really neat new set of programming patterns, which is rather than being so defensive, right? It's almost like fear-oriented programming. Like, and in many ways, like when you are writing code, you do want to be defensive, right? Right. So here, what I'm going through is an example using Jackson, where rather than deserializing into an object class, Jackson also allows me to deserialize in a more general way. What I get out of that isn't an instance of a class, it's an instance of something called a JSON node, which is provided by Jackson. And then I have methods that I can use to explore the structure of that node. Now, so for example, if I was expecting my JSON to have a particular format, I might expect that this piece of code down here would work and get all the way into the inner if statement. But look at how disgusting and tedious this code is, right? It's like I got to go step by step because if let's say the JSON doesn't have the shape that I'm expecting, right? Then one of these isn't going to work, and the risk here is that I have a null pointer exception, right? Instead of avoiding null pointer exceptions by avoiding null references in a case like this, I can just say, you know what? I'm cool with null pointer exceptions. I'm going to anticipate them, and I'm going to wrap things inside a try catch. And now you see I can just, just establish this one single line of code that uses method chaining to essentially traverse all the way into this nested structure to grab out that one value that I need, right? And the idea here is that it's possible that this call to get returns null, or this call to get returns null, or this call to get returns null, or this call to get returns null. I give up with the cat. I don't know what her problem is today. But instead of like handling each one of these nulls separately through this very defensive programming where I'm checking for null all the time, I'm just saying, you know what? It doesn't matter to me, right? Like if the first one returns null or the second one returns null, if there's something broken with this JSON and I actually can't pull this field out that I'm expecting to be there, I'm going to have to do the same thing, right? Like no matter where the problem in the JSON is, I'm either going to have to deal with that failure in a similar way. And so I just throw everything inside one try catch and I'm done, right? And so, if you find yourself writing code where you're writing a series of steps and a failure anywhere essentially jeopardizes the entire operation. And you're finding yourself having to put in a lot of code to deal with. Oh, I know what the problem is. Okay, mystery solved. The only thing that bothers her more than not getting enough food is not being able to get into a particular room. So she's in. That was what the problem was. It's like, what is she screaming about? Anyway, my wife had the door closed, so she's inside now, and all is right with the world. Anyway, so if you find yourself in that position where it's like you're doing a bunch of actions, sequentially, you're having to write a lot of code to deal with failures. Wrap it in a try catch. You know, you can even just catch exception. That's dangerous sometimes. Sometimes you want to be more careful to make sure that certain types of exceptions that you might not be anticipating don't get caught by a really general just catch exception, but that will work, right? And this type of code, and it's not always one statement. Sometimes it's a whole series of statements. And the idea is like, rather than worrying about everywhere that a failure could happen, you just wrap it in a try catch, and then you put all your failure handling logic into one place. It also can clean up the code a lot, because as soon as you stop having to worry about nulls and is the array, like there's all sorts of things you can not have to worry about. It's like, is this array index valid? I don't know, who cares? Just try it, see if it works, right? It's this instead of checking things really carefully, it's like, try it, see if it works. If it fails, have a plan, right? All right. And then I already talked a little bit about how to rethrow exceptions earlier, right? And this is something that I can do if I want to add some logging before the system dies or before things crash. This is a great thing to do on Android if you're debugging. Something's wrong. It's like, there's an exception here. Frequently, just knowing where the exception comes from is enough to figure out part of what's going on. But sometimes you want to know more about, like, what were the state of certain variables at that point or whatever. And this can be a way to do that. All right, let me pause. No, I didn't give her more food. You can't negotiate with cat terrorists, particularly about food, but you can open doors for them. That's a lot. So she spends a lot of time in that room during the day on the bed, and that's a place that she likes to sit in the window and look at the squirrels, because they tend to jump around in the tree outside that window. So anyway, that made a lot more sense once I figured out what was going on. I couldn't find her, so I was like, what is she screaming about? And then she's outside the door to our room. All right. Can I talk about the throw on line 5 of this statement? I think that's what the question is, or maybe, which line 5? Is it this one? Is it this one? I could talk about either. Great. The one above. Yeah, this one. So this is rethrowing, right? So essentially the try and catch mechanism gives us the ability to essentially intercept an exception, do something, like in this case I'm just doing some logging, right? And then allow the exception handling to continue. Like I mentioned, this can be a great thing to do, if I just want to know a little bit more about what happened. I don't want I don't have a plan for. So sometimes I use catch because I have a plan for how to deal with the problem. Other times I use catch because I just want to know a little bit more about what went wrong before the app crashes or whatever bad thing happens. Yeah. So how common is try catch? Very common. Yeah. I mean, because code has, I think one of the things, and this is something that, we can, let's see here. Let's look a little bit. We can look at the MP. Look at some of the places where try catch is used there. Let me power up Android Studio. And grab what is labeled as MP1 solution, but is not. It's the starter code. I guess it will become a solution set soon once I start working on the next checkpoint, because I'll use this as a starting point. Okay. So let's look at some of the places in this code base. Let me change this configuration here. Okay, cool. Looks good. So let's look at some of the places where we actually see try catches. Let's look at the server code. So this is a great example of a real world use of try catch. So this method is where when the server when our little mock, it's not actually a mock, it's your web server, when your back end, right, that's actually built into the app in this case. Normally we would deploy this on its own server and we would use a slightly different framework, but the idea here is actually pretty similar. So this is kind of the first place that when we make a request to this little server, this is where it starts running in this dispatch method. And you'll see that there's this thing called a recorded request that gets passed to the dispatch method that has a path. And what we're doing here is we're using that path to decide what to do. And this is very common, right? There are a lot of other, if you start looking at other more like complete Java frameworks for building web APIs, the path is frequently the starting point for requests. It's like, particularly for a GET request, right? For a GET request, the path is one of the primary sources of information about what the request should do. So I take that path and then I do some processing on it to figure out kind of like what's going on. The path, in certain cases, the path by itself is used to do something. In other cases, it's chopped into pieces like we do, where we pull off parameters from different parts. Sometimes it's combined with other information. There's a bunch of different semantics here, but the path is frequently a starting point. And so what do you see here, right? So I see a try catch. And how does this work? Well, here's this initial sort of path handling. It's almost like a switch statement, but it's an if else, right? But it's basically like figuring out, okay, well, if the path is just the root, right, then I do this. If the path starts with summary, I do this. If the path is null or the method doesn't, the method is like get or post or head. These are the different HTTP request types. If I drop through here, then I return not found. But look at what I'm doing if there's an exception. And so the idea is that any code paths that start inside this dispatch method, if they throw an exception that gets thrown out of the method, what I'm going to do is I'm going to return an internal error. And that can be any type of exception. That could be an unchecked or a checked exception. So if your get course method throws a null pointer exception, your server is going to return 500. Some of you may have seen this before if you've been browsing around the web, or you may have gone to a website that's not working right now, and you get like a 500 error. A lot of big web providers have kind of like funny pages that they'll send you to when you get a 500 error. We used to have one for the CS125 website that had like an update, the logo upside down, which is like a distress symbol, right? That's like a polite way of telling the client like something broke, like, and it's usually a bug, right? I mean, usually when you see one of these 500 errors, so if the HTTP error codes. There are 400 error codes. So the 400 error codes, those indicate the server worked properly, but you didn't, the request, there was something wrong with the request. So 404, like I don't have that document, or I don't know how to service that request, right? There is a 400 request that indicates that there's something else that's malformed about the request. You have a 401, which is an unauthorized. That means you don't have permission to view the document. There's a whole litany of these 400 requests. There's one like 428, which is payment required or something, which is you haven't paid me to use the API or something. Anyway, a 500 error indicates that something's wrong with the server, right? It's like it's that. So you think about it, like you make a request to the server. 400 is the server saying it's not me, it's you. 500 is saying it's not you, it's me. Like something's wrong, right? Like there's buggy code on the server. So a 500 request, a 400 request, like if you get a 400 request back from a web API, what you need to do is figure out what you did wrong. If you get a 500 request back, it's possible that your request was totally valid and the server is just busted, right? And so somebody might fix something later and sort that out. So one use of try catch in here. Let's look down here at the so let's look at the server start method. So this is actually, so if you look, this gets called in the application code that gets started when the app starts up. This is this pattern of sometimes it's known as sort of a singleton pattern. So the server is we create an instance of the server, but we only want to ever create one. And so what we do here is we combine a private constructor with this static start method. You'll see we maintain whether or not the server is started in this Boolean. If it's not started, we create a new thread to run the server. This is one of those places. Remember, I was talking that there are actually multiple places that your code is running at the same time. This is one of the places where we start one of these new threads of execution, and then we mark it as started. So we look down here at the constructor for the web server. And so this is code that's from the documentation on how to use this particular server framework. We create a server, we start it up. You'll see that we start it on the port that you've configured. This has been causing some problems for people where that port might conflict with other things that are running on your machine. And this is a case where you'll see that I'm actually rethrowing a checked exception as an unchecked exception. And really, I should probably have used just E rather than e.getMessage. I don't know why I did this, but yeah, this is an example of rethrowing a checked exception as an unchecked exception. Because there's no way to handle this, right? I mean, what needs to happen here is the program needs to crash. And that's what does happen. Okay, so that's some examples. Same thing down here in some of our code. So, Jackson can throw these problems, and here's another place where I'm just rethrowing the exception out of the catch block because there's no real way to handle this. These are exceptions that really shouldn't happen, right? This would have indicated something was broken with the code that we gave you. Let's look at the client, right? So, and this is in code that we've given you that I wouldn't have expected you to look at carefully because it's not code you have to directly modify. But when the client starts up, so some of you have seen error messages from this when you start up the app. There's this sort of dance that goes on when the app starts, right? Which is that there's code that runs the server that gets started. And that takes a few seconds for the server to start up. At the same time, remember that's one part of the code that's now running independently from other parts. At the same time, the client is also starting. And the client is trying to make contact with the server. So what happens here is that we start another thread that in what this loop does is it periodically, you'll see that it's down here, it's sleeping. This causes the thread to just stop running for a period of time. I think it's like a second, is what we've configured. And what it's doing is it's trying to connect to the server. And one of the reasons that we do this is because until we connect with the server, we can't actually handle any requests that are made to the client. So you'll see that once this succeeds, we start the queue of HTTP requests. We can't actually do that until the server is ready. And you'll see, you'll see right here, and I probably shouldn't have had this be an E. It's another mistake on my part. This probably should just have been a warning or an info message, but you'll see some errors generated by this when your app starts up because it takes the server a couple seconds to get going, and in that time, the client can't connect. So it's trying to make this connection. If it works, it disconnects and then starts the queue and then breaks out of this. If not, we continue to loop, right? And this is a place where this is sort of that catch. In here, the idea is that the failure is probably generated by this connect method. That's what's going to generate a failure. If I don't, so this is a case where I'm retrying something a few times. As soon as I fall through the try block, I break out of the loop and this whole thing ends, right? And that's actually what indicates that the client is now up and running properly. So yeah, I mean, try catch is a really common set of idioms that you see used in real code in a lot of places. Yeah. If you don't have a 500, I mean, look, even a 500 error indicates that the server is sort of working, right? You can certainly get web servers into a condition where they don't return even 500 errors, that there's something so broken. If you can't... Actually, it's really interesting because one of the things... So when you go to a website and you actually get a 500 error, what's interesting is the website is working well enough to send you the 500 error. And there's actually kind of an interesting strategy so if you look at that page that you get shown by certain websites, it's sort of like once you're in the process of trying to respond to a 500, like once you're in a situation where you're actually returning a 500 error, you actually start to get very defensive as a back-end web program, because you're like, there's all sorts of things that could be wrong. And so I actually want to keep those 500 error pages very simple and very small and lightweight, because I don't know what's wrong with my system at that point. It's possible that, so essentially, like, there's certain tools that people use to kind of generate web pages dynamically. That's how all these websites work, on the back end. But if I'm at the point where I'm about to generate a 500 request, like, something's broken. And I don't know what it is, probably. And so I need to be very, very conservative about what I expect my web server to be able to do at that point, right? So a lot of times, like, a 500 request is, you'll notice tend to be very simple, and they're very static, right? Because a lot of times I think they just generate all the HTML for that page and put it somewhere, like as a static file, and because that's the simplest thing that you can do when something goes wrong. You don't want to rely on anything else that might be broken. So anyway, all right. Other questions? Great questions today. Let's go back and look at this. See if I can find other places where we use try catch. I don't think so. Not in here. I've tried to keep a lot of this really simple. Let's see any try catch in here. Yeah. And networking code frequently. So if you think about, one of the ways that we use try catch is obviously to respond to changing conditions in the world, right? There are errors that are caused by mistakes you made in your program, and then there are errors caused by changes to the environment that your code runs in that are out of your control. And this is particularly true whenever you're writing anything that works with the network, right? If you're writing code that runs on a machine that's like hardwired to the internet, you can get away with ignoring some of these things. It's way harder to do on a realistic mobile app. And this is something that we're not testing in your system, and that's okay, right? We're just getting you started with Android. But a real Android application, think about it. I mean, as you move around, maybe not as much anymore, but in the past when people went places and did other things, your phone is constantly, the networking environment around your phone is constantly changing, right? So and this is one of the things that's really fun and really sort of interesting and challenging about writing mobile apps, is that, you could be in a situation where, like, one moment you have a really fast Wi-Fi connection that's free, and then 2 minutes later, the user walks out of their apartment and suddenly you're on a slow mobile data network. And this is less true in the US, but it's very common overseas, that those mobile data networks are metered, meaning that you are paying per byte for the use of that network. And so let's say you're in the middle of like a big download or something. Because let's say your program, let's say it's like a music app or something, and you were like, this is, the user's at home, and their Wi-Fi is really good right now. This is a great time to start downloading some of the songs they've been listening to recently, so they don't have to download them later. And then suddenly they throw you in your pocket and they're out the door, right? So there, and this is and for a minute you might not even be able to connect at all, right? You might have had an existing connection and suddenly it's gone, right? Because when phones move between different types of networks, frequently that involves disconnecting and reconnecting to a new network, and there can be some disruption caused by that. So anyway, so that's a common place where you see the need for error handling, right? Because, on some level, particularly on a mobile device, whenever you're using the network, things could go wrong at any time. If you built this and you deployed it, you would have to deal with the fact that, for example, a user's on the summary page, right? So you've loaded the summary, awesome. You also probably don't have to load the summary that often because it doesn't change that often. So there's this whole game that you can play with caching information, which is kind of cool. Maybe we'll put up some ideas about how to work on that as part of the final project. But now they click on a course. And so you're like, I'm going to make this API request to get the information. It's like, dope. Nope, you're not. Network's gone. What are you going to do, right? Hopefully throw up an error message and not crash, right? But a poorly designed app could crash in that situation, right? Or just like, it would show a blank screen. That'll work, right? That'll fool them. It's like, I want more information about CS173. Okay, blank screen, right? So anyway, this type of stuff, like as soon as you do enough programming, particularly with mobile devices, you start to get pretty cognizant. I don't want to say paranoid, but at least careful, right? Cognizant of the fact that stuff shifts, right? The environment around you is changing a lot. A lot of that's caused by mobility. But even for other types of computer systems, there's nothing really different about it, right? Failure is a part of life. Good questions. Other questions before we take a break for the weekend. And it is, again, if you are in Champaign, man, like, do not blow this weekend. It is going to be so nice. And this is not normal. There was snow on the ground last year around this time. Certainly cold enough, if I remember correctly, to snow. We are just getting a beautiful gift of this sort of spring-like weather this late. Particularly given what's going on in the world. We're going to be cooped up for a couple of months, so I certainly am going to take the opportunity to get outside today and get some fresh air. Are we going to have a task to make our code cleaner at the end of SMP since we do mimic lots of codes? I don't know. You're welcome to make your code cleaner as you go. I don't know if there's a... So mimicking code is not necessarily making dirty code. The code that we've given you, what we've tried to provide you with is stuff that's pretty idiomatic, right? Like, I think this is pretty good code, right? I wrote it, so I'm biased, but yeah, we try to show you the right ways to do things. And so if you copy the right way to do things, frequently what you have is more of the right way to do things. What you might be getting at is like there might be some opportunity to simplify some things and combine some stuff together, and that's absolutely true, and I don't deny that. Now, I will caution you that as someone who's done this for a long time, the urge to kind of, I don't know, my wife likes to call it the urged purge when she's getting rid of stuff in our house, so maybe I can use the same term to talk about code. The urge to purge, the urge to try to take like 3 methods that look similar and turn them into one method that's slightly more general can backfire. A lot of times so in some computer science courses, there's this real emphasis on like never cut and paste code. I think anyone who thinks never about anything in programming has just not written enough code because there's really never, right? Never is always too strong of a word to use to describe anything that we do with code. Hey babe, is that for you? Yeah. So cut and paste has its place. There are times when particularly two somewhat similar methods, like for example, the get course and get summary. You can certainly try to rewrite those into one. I think that the one method that would solve both those problems is probably going to be worse than 2 similar methods. And again, I've done this a lot. I tend to have a tendency to really enjoy rewriting things and restructuring stuff. And And so at times I convince myself that this is a worthwhile activity, and so I'll be like, oh, I'm going to rewrite this and it's going to be so much better. And here's how that journey works. So, it's like you have something that works. Okay, so it's like you took a hike and you got to a particular spot. And so now there's this tendency to want to kind of like back up, start over, and be like, there's got to be a better way to do it, right? And when you're starting over, it feels really exhilarating at first because everything feels clean, and it's like you're making a lot of progress, and stuff feels like it feels like it's going to work out better. A lot of times, by the time you get to the finish line, it's not better. It's just different. It's newer. It's got its own problems. You have solved some of the problems with the original version, and you've introduced some new problems, and the stuff that you thought would work out better might have worked out better, but then along the way you realize that things that worked out well worked out the first time, worked out more poorly, and a lot of times it's just a wash. I'm not saying that's always true. I mean, certainly people do rewrite projects and make them quite a bit better, and projects can certainly get to a point where that is really beneficial. But I would just caution against that, right? I mean, as ugly as the code might feel to you, working code is nothing to scoff at, right? When it works, when it solves a problem, when it's meeting a need, when it's doing some good in the world, that's something to be proud of. And you will rapidly, particularly if you move on and start working on something else, you will rapidly forget about code that's not causing a problem, regardless of how god-awful it is. I mean, there are probably parts of the course website, for example, that I would cringe to look at this point. But you know what? They're working. And so I have moved on to other things. But anyway, so we're the last part of the MP, we're kind of going in this pattern where it's like, we started off, you guys having some little fixes. Then this part, there is some mimicry involved. Next time we'll do it'll be a little bit more of a push to get you to work independently, and then for the final project we're actually going to just set you loose and say do what you want. This needs to be an improvement on the existing app, but we'll cut the string and say, and again, this is kind of something, it's almost a very, very compressed version of the kind of onboarding that you might have at a company, right? Start a project, fix some bugs, that's step one. Extend some existing features, that's step two. Propose a new feature and implement it yourself, that's frequently step three, at which point you're kind of considered to be an independent developer on the project. All right, I'm going to sign off. Hope everybody's doing okay. Enjoy the weekend. Like I said, if you're around the area, please get out and enjoy the mid-70-degree weather. Won't last forever. We'll be back on Monday. So we do have a lesson on Monday next week because it's going to be a Monday to Thursday week. And we'll give you some time at the end of the week, particularly given that the MP deadline is Friday. I will look forward to seeing you all on Monday.